All right, so it's officially 5 p.m. European time. So it's the official time to start the webinar. So thanks everyone to joining us. So maybe good morning, by the way, or good afternoon, or good evening, depending where you're based. This is a PAC webinar, not a Neotys webinar. So for those who have been had the chance to be part of the World Virtual PAC that happens last year in June, 6th of June, by the way. So this is like a sort of an appetizer of the virtual PAC that will happen in a few announcements to do today about the PAC. But today it's a really special edition because we have two of our PAC member. We have Scott Moore and Wilson Moore that are with us today. So just before we go further, I just want to remind the housekeeping rules. Remember, it's a webinar, which means you don't have the audio, so you don't have the ability to ask questions directly. So don't worry, if you have anything, if you want any questions during that webinar, there is a question panel in the GoToWebinar widget, so please drop your questions. We will have a Q&A session for Scott, and there will be a Q&A session with Wilson later on. And of course, if we don't have the time to answer to all your questions, we'll get back to you later on. But also, I just want to remind that this webinar has been recorded, and the recording will be available in the PAC website. Okay, so one of our announcement today is the virtual PAC. So the virtual PAC of this year, the theme is PAC to the future. So if you like the movie, if you if you like the fact that we're going back to the past and talk about the old way to build performance testing, or you want to jump to the future and see how we deliver performance testing in 2040, for example, that will be the event where you should assist. So just to want to remind, so the official date of the event is the 24th and the 25th of September. So it's a 24 hours live streaming event. The call for paper has already started. Remind that the deadline of to submit your paper is the 31st of May. So please, if you want to share your experience, if you have any awesome things you want to expose to the community, I will recommend to submit your talk. Otherwise, we will start to promote the event, and you will be able to start to register to the event from the 7th of June, where we will have the official lists of the speakers for that event. So just to remind, 24-hour PAC, the virtual PAC, the concept is a 24 hours live streaming session where we follow the sun. So we will start at 5 p.m. New Zealand time, and we will follow the sun to reach to California. So there will be dedicated speakers per zone. Speakers for the Australia, Ireland, India, and then we will move further to Europe, and then US East to US West. If you are based in any of those locations, I mean, if you're part of the world, you could be basically part of the PAC. And when I say US West, I'm including Hawaii, Samoa. No, Samoa will be probably, I don't know, but never mind. If you are a part of those the islands, we would be more than delighted to hear about your experience as well in performance. So just for those who are not familiar, who are the PAC members? The PAC members are obviously experts that has been involved in performance testing. They like to share their experience. So training is one of the things. So sharing methods to the community. It's going to be also people who influence the market that could help new people that start doing performance testing and who wants to get some recommendations. That could be also one of the aspects. Also, the other thing is a commando. So that will be a nice introduction for Scott's presentation. A commando, someone who is not afraid to going beyond the traditional path, which means if there is something that is load testing from another angle or another approach, you maybe can share also experience. So don't. So if you have those different things in your skills, or if you're working like this, we need you. So please, like I said, submit your paper before the 31st of May. All right, without waiting, today's webinar is going to be a webinar with Scott Moore and Wilson Marr. So Scott is going to talk about SEAL, so software engineering across the life cycle. For those who doesn't know Scott, it means you're not connected. You've never been in LinkedIn. So I think you should probably ask yourself a few questions, because Scott is super active in Twitter, in LinkedIn. He's always jumping on questions, pushing some problems, and I think it's you should, if you're working in performance. I don't know how you cannot be aware of this name, Scott Moore. So Scott Moore is working for Scott Moore Consulting as well, but also he's going to have a company called Simple APM. So if you're looking for a great APM product, you should reach out to Scott for that. Wilson Marr. I mean, from my perspective, when I started load testing, I searched for blogs to learn how to do load performance testing, and I found a great blog that was written by Wilson Marr, and so he's for me it's a big influencer, and he has always have great blogs, really technical, go deep on the topics. So if you never heard about that name, it means you should search it on Google, because there is many things that Wilson has built, has shared. It's an awesome performance engineer and evangelist. Today, Wilson is going to talk about consideration for cloud performance and scalability, the specific limits and monitoring. So if you're doing any cloud, working on a cloud architecture or cloud, if you have to load test cloud solutions, there are a few things that needs to be considered, and I think project needs to handle and manage the costs, and I think that will be one of the things that Wilson is going to talk about it. Before anything, you want to add something with Scott or Wilson? I think, Scott, you're muted.
No, I'm here. Can you hear me?
Yeah, I can hear you.
I was just going to say, there's been so many projects that would have never been completed if Wilson Marr's website hadn't been up, including some of mine. So thank you, Wilson.
Thanks, Wilson.
Well, thank you, Aaron.
All right, so without waiting, I will give the rights to Scott. So Scott will be the first one to present, and then Wilson will follow afterwards. So, Scott, without waiting, you will be the presenter now.
Okay, show my screen. Let me know if you can see this presentation in full screen now.
So we are seeing part. Yeah, I can see your presentation. Yes.
Okay, probably a little bit of delay there. Okay, well, thank you so much for having me, and it's always a pleasure to get to open my big mouth, as I always do, and talk about a bunch of stuff around performance. But the Performance Advisory Council is kind of special. I've been wanting to talk on this for a while, so I'm really excited. I got a lot to talk about, very little time to do it, so if you don't mind, I'm just going to jump right in. What I want to talk about today is about the software engineer across the life cycle. This is something that I actually came up with. It's a different job title that is more of not an alternative to an SDET or an SRE, but I would say it's a superset of an SDET and SRE. I'll get into more detail, obviously, but I did want to tell you kind of, we're going to start by talking about where we're currently at in IT, where we've seen things going over the last 3 to 5, 7 years, and seen how lean methodologies like Agile, the DevOps culture have affected IT, the rise of the SDET and the SRE in the industry, and all of these changes really make the performance engineering role and performance testing role have to make changes to how they deal with the rest of the IT landscape. So engineers are having to respond to how do we deal with these emerging changes that have happened? So that's the reason why I was thinking there seems to be something missing, in my opinion. So I just want to bring this to the community, and I'm happy to get you guys feedback on what you think about this, right or wrong. We talk about how the seal would work in a real world application and kind of the ROI or the value that it brings to the business in real terms. So first of all, I think all of us would agree that when Mark Anderson said software is going to eat the world and software is eating the world, I think we all agree it is. We're there. We're beyond that. The problem is, as a tester and an engineer, very seldom do you hear people talking about the fact that we have to deal with the mess that's left over after you have eaten the world, and we have to be the cleanup crew. And we are building more software than we've ever built before, but do you know what that means? This is an ode to the next PAC, by the way. This is my favorite movie theme. It means that we are building some of the worst performing software ever, and more of it than ever before. Functionally, secure, security-wise, and performant. And as you can see in the bottom right corner of this slide, it keeps me in a state of unhappiness. And why am I so unhappy? It's not because I didn't eat barbecue today. It's because I don't see us learning from the mistakes of the past. We have all this great new technology. I'll talk about some of the trends that we're seeing that should be solving a lot of the problems, but we still see the same failures on Cyber Monday, Black Friday, and complaints all over the internet as to why sites are slow, why we're having outages. Why is that? I think it's not just a failure of technology, it's a failure of the skill set involved. So on the bright side, that's how I've made my money over the last 15 to 20 years. So what, I got another 15 or 20 left to go. So am I really mad about that? Not really, but I do want to try to share something that hopefully will solve some of your problems in this webinar, and maybe the seal is a way to begin repairing some of that. So let's talk about kind of what we've seen over the last few years. We know starting with, I think it was 2017 is where on Cyber Monday we started to see the breach of more than 50% of the users that are shopping are doing so with mobile devices. So they're shopping with their phone or their iPad or tablet, whatever. And that is further degrading, that means that their experience will be further degraded when the network is degraded. We've moved our applications and our infrastructure into the cloud. And we all know the cloud has unlimited scalability, right? So why do we still see sites down, sites slow on Cyber Monday? For those sites that are already in the cloud, there has to be something else going on. We've seen agile and scaled agile. In other words, we've seen agile organizations take over their methodology and remove waterfall. And I don't think anybody would disagree that taking smaller units of an application or code and moving them out and being able to pivot to make sure you're building the right thing before you get fully invested in it, that's a great idea. But when you try to scale that up to 50 to 60 small agile teams across a huge application portfolio, that gets very complicated very quick, and we're seeing troubles in the industry trying to scale that out. We see the move to microservices, serverless architecture, infrastructure as code, and thus we have more talk about DevOps than ever before, where we need the breakdown of these silos, where development and QA are working closer than ever before together, where they're kind of rolled up into one, and include security in that. And they're also talking to operations, and that's why we have the site reliability engineer being talked about so much today. Another trend that affects performance engineering and how we behave and respond is the move to machine learning, AI algorithms, and taking all of this noise that comes from logs and monitoring, and we've got to make sense of it faster. Can we somehow use technology to clear the noise that we don't need to see and let it filter up the things that are important to the business? All of these things that are beginning, that we've seen over the past few years and we see beginning to trend and that we're in the midst of, all affect how performance is dealt with in whatever life cycle you're choosing to implement. And that means, yes, a shift left for sure. Yes, a shift right. But when we begin to talk about shifting left and shifting right, how far do we go with the current SDET and SRE? And that's what this presentation is about. So, fundamental problem. Let's talk about performance in general. This is what I call the performance widget. And James Pulley actually developed the first version of this, and I think I just colored it gold. I added the 4 horsemen of the apocalypse on the top left there. And what we're trying to say here is this widget represents the resources that are being given to your application. Even if you think you're using quote-unquote serverless architecture, we're not defying the laws of physics. There are servers there somewhere, and as these resources begin to be depleted by the number of times that you use them, for the duration of time that you use them, as they begin to give out, the 4 horsemen will begin to show up to ruin the user experience. Having an outage, a degraded network, just a long time to get the screen rendered or get your purchase validated. And the longer that things take as we move from the left to the right, the more it's going to cost you in real financial terms, but also reliability and your reputational cost. And that's huge. So when we think about performance, we can no longer just think, I'm just a performance tester. I'm just within QA. I don't have to worry about development. I don't have to worry about operations. I just run my little test, throw them over the wall. Those days are gone, and you're going to have to think differently. You're going to have to think as a performance engineer. So when we talk about performance testing, this process that I'm showing you here on this slide, this is what I actually use when I go to consult at organizations. So when I talk about just your standard test project, this could work for waterfall, this could work for agile, this could work for whatever, but it is in either case an iterative process, which is why it's a circle. So we have the planning of analyzing, what are you going to do? How are we going to strategize around testing this? What's the protocol stack? Give me the who, what, where. Then we begin to build our test. We automate our business processes. We execute our test. And then we look at the test analysis and report back to whoever we report to confirm, are we meeting the performance requirements or not? And those of you who have been doing performance testing for any length of time, you recognize this process. And you probably recognize the deliverables. We have some kind of a test plan, project plan. We have an execution plan. We have created scripts, we run tests, and then we produce some kind of a report. When I run my test scenarios, this execution portion on the bottom right is kind of what I start with. I can alter it at any time, obviously, but we start with the baseline. How long does it take a single virtual user? As we increase the amount of load, do we begin to see the trends of how long certain things take or resources that are becoming depleted? And then we will reach whatever that full 100% load is. We'll try to go beyond that, and we may actually just try to break the application to see where the first point of failure is, which would be a stress test. So all of this is your traditional performance testing process. What is going to be different depending on if you're waterfall, safe, agile, DevOps, it might just be the scope. So the scope these days might just be, we redid a web service and we just need to test this web service, and we're going to throw an automated, we're going to change our script just slightly, throw it back into a CI/CD pipeline, and within minutes we've got this thing tested. So the whole process may just take minutes or hours or one day versus taking sort of a 40-hour week or a 4-week process. When we move into iterative, we just take that scope and we take that iterative process and just move it into those increments. So each one of these iterations might be a 2-week sprint. So you would do the whole planning, building, execution, and confirmation all within that sprint and report that out to the business. In good lean methodology, as code is being written, test cases are being written, automation is being written, and tests are being run on the unit, at the unit level or at the smaller scope level. And then when you get to the end of your final increment to where you're ready to start planning, or the next major version or whatever, you either have to do one increment that's dedicated during a planning increment to kind of validate the thing as a whole, right? So an integrated test, but because the integrated test is at the very end, since you've already done all of this work ahead of time and built it and tested it as you went, it really does become a check mark at the end of the cycle, but in a good way, because you're just revalidating things that you've already tested. And this is where we get into the idea of scaling this kind of thing up in scaled agile, or what we call SAFe. And in my opinion, SAFe is probably the closest thing to herding cats. And if any of you have ever been to a SAFe class, I've been to the consultant class to get certified, you will recognize this next slide. This is what this is actually, I think, a minor version behind, but this layout, every single thing, every image, every word on here means something. And along with it, it comes with its own terminology. Some words semantically you've heard before, but they may have a different definition when we talk about SAFe. The biggest thing about SAFe as we scale agile is the mindset of moving the performance testing and performance engineering into the system team, which is over on the left-hand side where you see the number 1. So it's the middle thing there. System team is where performance and quality and security testing all kind of play a role. And then as you look towards the right where you see that, it's kind of a smaller version of the slide I showed a couple of slides ago, where you see all the increments where you're enabling, you're putting features, you're putting enablers in there. Each one of those cycles would have that performance testing cycle. All right, so that's one way where the performance tester, not even an engineer, but a performance tester, can insert themselves into a scaled agile, a release train across many organizations and be part of that and fit into that whole cycle very easily. The cycle, if you stay with that process, it stays the same, no matter how small or how big, and then we could take that, and maybe for this project, that's what we've been doing, but we still have one organization over to the side that still does waterfall methodology. We can still use that same process to work that project as well. So as we move into things like DevOps, and where Dev and QA are kind of rolled into one group, this is how some of the industry giants have tried to create job titles and responsibilities to deal with that. And they would be like Microsoft. They develop the software development engineer and test, which it's not just a developer, it's a developer that can develop as well as any developer on the team, but they have a true testing, QA, analytical mindset, right? I have heard that this exists. I have yet to see this actually exist. Unfortunately, and this is just my experience, I'm sure it's not everybody's, most of the time I see this as just an additional headcount into development, and it's kind of taking advantage of the budget that's available for development. Hey, I'm adding a tester, but I'm really increasing my headcount for development. They still roll up to the same manager, and there's still that conflict of interest where there should be a separation of that. Just my opinion. Okay, you can share your opinion later. Google, on the other hand, has a different approach to this, where they created the site reliability engineer to be, I call this the find it and fix it people. So you maybe have a support desk that has, or a ticket that has been created because you find a problem at 3 a.m. in the morning, and you have a team that's on pager duty. Person who gets that information, they may be part of the research team in operations that finds that problem and says, hey, there's this, this is going on, but they also might have to go and dive into some code and recompile a driver and redeploy that out through the whole continuous pipeline over a period of hours to get that through from testing, a QA environment, a staging environment, and into production. They may be the person who does all of that. And what Google does is they keep you doing 50% development and 50% operations. If they find that you're spending more than 50% on either one of the sides of that fence, they take you off the SRA team and put you, like if you like development and that's where you tend to lean to, they'll put you in the development team and move you into a dev team, because that's obviously your calling, right? So this is a team and this is a company that, they make performance part of their culture. They believe that there is not really a problem in IT that you can't solve with some type of automation. And they also believe in measuring things, which is really good too, because what gets measured gets done, right? So that's a good thing to have. But here's my problem. This is me, okay? This is Scott Moore, okay? Take it for what it's worth. I did stay at a Holiday Inn Express once. I still believe developers still make bad testers in general. There are obviously exceptions. I also believe developers make horrible pure ops people, and developers typically, especially junior developers, make horrible customer advocates. They're not thinking necessarily about how their little bubble affects the business as a whole. You have a reason sometimes to have silos. Silos aren't always bad. It depends on the situation, the company, and the way that you run your company, right? We have the idea that we're only going to hire these special rock star people. We call them purple squirrels. We call them unicorns. They can do everything. They can code. They can run a company. They can, sell. They can market. But you know what? You don't build a company based on rock stars and heroes. You base your company on everyday heroes, the people that do what they do, and you need a team. If you think about how some of the best movies like Back to the Future have ever been created, it was a team of people that they brought together that were specialists in what they do, and what they come up with when they finish that recipe is something really great. And I think that's the way IT should be. But we don't base our company and our success on a purple squirrel. Here are some of the current industry titles that many of you probably that are watching this webinar, you fall into one of these categories. You're in QA, you're a systems engineer, you're a performance engineer, maybe you're a performance architect if you're a senior person, but you generally play in the testing and engineering realm. And that's why today I want to introduce you to the idea of a SEAL versus an SDET when we talk about an entire life cycle approach. This is the problem. We have these different areas here: development, testing. I would call that QA, but that's where performance testing generally begins in earnest. You have probably a staging environment that looks a lot like production as well in that silo right there. Then you have operations, but then the forgotten one is always that one on the far right, which is the business itself, which may not understand anything about performance testing, performance engineering. When we look at the performance tester, they're typically playing in this left-hand side realm, and they work with development, they work in the QA realm, they do their testing, and that's it. The SDET kind of creeps over into operations as well. The SRE does as well, but they're still playing in that IT role. What a software engineer across the life cycle would do is be able to talk to people who are working on the initial requirements before a line of code is ever being developed, work through those performance issues even before the code is finished, work with development as the code is being developed, as it's being tested, as it's being released, and also be able to sit down, if needed, with the CIO and explain to them why they need to think about re-architecting the way they've done their business so far, because this is how it affects performance. But I didn't say that that person is going to know everything about everything, right? This is the key. The SEAL is a specialist with a very narrow view, but goes across a very wide range of areas, right? So the only thing I really care about when I describe myself as a SEAL, I'm going to work with development, but I don't want to talk to them about how they code writing reports or what. I care about how well their code performs. That's it. That's what we have in common. That's all I want to talk about. Same thing is true for requirements. I want to look at requirements and see, are they putting performance requirements in there? How are they addressing this? And hey, we built something like that 3 months ago that looks a lot like what you're designing here. Let's not make the same mistakes that we made before, right? And when I talk to the business, I'm not going to tell the CEO how to run his business, but I am going to advise him on how his business is being affected by poor performance and why all those people on Twitter really aren't happy with them right now. So how is a software engineer across the life cycle, how is a SEAL different from some of these others? What are they like, right? So obviously this is a person who probably does have a QA and probably some development background, but they're probably not going to be this huge code junkie, right? They're writing code for the purpose of, I need to write code because I need to get something proven or tested, or I need to show some kind of a result. So they're trying to solve problems all the time. They really get technology. They understand the technology stacks. They understand what serverless is, what Kubernetes is. They understand what all this is, but they don't geek out on it to the point where that's all they focus on, right? They are a customer advocate, and they have true consultant skills, which means they know how to communicate well. They know how to talk to people. They know how to write something up where people who may not always be technical can understand what they're talking about. What kind of things do they do? Pretty much everything. They'll look at any requirements that would affect performance. They'll look at your backlogs for developers, and they will address, hey, you're not really thinking about what you're doing here. You need to think about how this particular code segment here affects performance, because that's going to affect this weight on the backside. Well, it works on my machine. We deal with that kind of stuff. They can look at units of code, but they also have an end-to-end view as well. So I think I'm getting close. I think I'm just about out of time. Let me see if I can finish this up here real quick in the last couple of minutes. This diagram here really shows the gamut of where performance engineering as a whole kind of plays. And notice that we've got business and contracts in there. That's not something I've really seen a lot when we're talking to a technical crowd. But how many times have you been to a business where they said, hey, we want an agreement that's written where we both agree in a contract that you, vendor, have to give us this level of performance, or we're not going to pay you for the software, or we're going to get somebody else to do it. There's a lot of talk about that, but I don't see a whole lot of that stuff being done. Is it practical? Maybe in all cases it's not. But is it still part of performance engineering? I believe so. So you got to think about the whole gamut of what performance engineering takes up. And then finally, how do we relate that back to real value to the business? In order to do that, you need to have some kind of a performance indicator. And in order to do that, you've got to look at things like people, process, your end users, your customers, and obviously how it affects you financially. So this is just a list of general areas that you should look at and start with, but it's going to be obviously different for every company. But financial, it's easy to see. Because I have better performance, am I making more money, or am I losing less money? And for example, we already know that if you're shopping on a shopping cart and you can reduce 1 second off of that purchase, you're going to get somewhere between 7 to 10% better conversions. So if I was able to tell the CIO, hey, if we can speed that commerce site up by just 1 second on the checkout, it may mean up to 10% financial improvement. You don't think that's going to cause some kind of positive reaction to happen? And that's measurable, right? So you begin to start looking at things like that. Look at how the sentiment changes across Twitter and across your support tickets. Are you keeping more people in your company because your customers are delighted and your employees are delighted to work there because they're meeting a need that their customers want and they see value? So you start looking at some of these KPIs and relate that how performance improvement is definitely making a positive impact on the business itself. So a SEAL, a software engineer across the lifecycle, would be able to help you with coming up with these KPIs, putting measurements around them, and still working in the same realms that we always have as a performance engineer and a performance tester. So we should be able to handle the technical capabilities as well as some of these non-technical capabilities that I've mentioned. There's an article that I wrote on LinkedIn, Do You Need an SDET or Do You Need a SEAL? I would highly encourage you to read that and how I came up with it. It's got a lot more detail that I can't cover here, but it may answer some of the questions that you have about why are you choosing a SEAL? Why are you doing this software engineer across the lifecycle instead of just going with the flow and being an SRE or being an SDET? So I hope I've helped clarify some of that, and I think with that, this is the conclusion that I came to, which is the SEAL addresses the entire life cycle, and they have a primary focus, which to me is performance. You may be a security or something else, but performance is what I do. And never forget, it has a lot to do with, are you passionate about what you do, and do you actually have experiential knowledge? In other words, have you gotten your hands dirty and do you have knowledge of somebody who's actually done it before, or did you just read a bunch of articles and now you're presenting to me and telling me how I should do it, but you've never done it? So coming from somebody who has had to do that, that to me is the best way. So thank you so much for having me, and I'm going to turn this back over to you.
Neotys. Maybe before we have Exactly 5 minutes before we passed we gave the rights to Wilson to be presenter and
Are you
present
saying
his
I was on time?
You were almost on time. I had 5 minutes, but I was almost at the end, so I didn't want to cut you. I think it was quite interesting, especially at the end. It was really important stuff, so I didn't make any comments. I think one from there is no major questions. There is one about your Twitter account, but we will answer that at the very end. One of the things that I pops in my mind is let me probably we have a lot of performance engineers with us today and a lot of performance tester. If I've been involved in performance testing dev and staging or pre-prod and doing few ops, how can personally me can change my working or my methodology to become a SEAL? How can I start worrying about the business elements, all the things? So how can I basically, how would you recommend someone that is currently working as a performance engineer to be a SEAL in the next coming years or next coming month?
The first thing I would recommend is to take initiative, self-motivation, self-discipline. I chose the acronym for SEAL on purpose. I'm thinking about the Marines, the SEALs that do the really heavy lifting in our military in the United States. And not that a performance tester or performance engineer is anything like what the actual military has to go through. So don't take that the wrong way. But this is, I'm trying to just convey an image that it takes self-discipline, self-motivation, and self-initiative to drive that, right? You may have to, a lot of people are told, hey, you stay there, you run your test, you churn this out, and that's all you need to do. If you're happy working in that environment and that's all that you think you want to do, well, maybe you're not a SEAL. Maybe you're just not one of those people. But if you desire to be that, you are going to have to get out of the box. You are going to have to get out of your lane. That may mean having a conversation with your manager, your manager's manager, or whatever. But the way that you do it is not by coming up and saying, hey, the performance here, I'm doing testing, it still stinks here. You have to come with a solution, right? So that's that self-determination of how can I improve something here? I guarantee you that if you go to any boss who is any kind of a leader and say, did you know that if we could improve this by this much time, that we could actually make more money or save more money on these in operations, I guarantee you they will give you their time and attention and probably let you run with it if you're willing to do that. So that's the biggest thing I could say that you start with.
So wake up at 5 a.m., do some workout, eat vegetables and clean food, and be initiative. Make yourself invest in your project. Point out. Don't be shy of bringing new things for the organization.
Yeah, and jump in cold water every day.
That's right. That's right.
Well, Scott, I hope that this whole thing will reduce the amount of jobs out there. I would say probably within enterprises, what I've seen, probably 90% of the companies, exactly what you said, is that they just said, well, this is your swim lane, and just we don't give you access to this and that, and just do your freaking job, right? And then and I even had this one poor guy tell me that, yeah, we have an innovation department, so you're not in that, so just shut up. There's a lot of people like that. So my question is, how do you find jobs that are this oriented, where people can become SEALs, right? I mean, I know that to be a SEAL, you have to get a letter from your senator and all that. But how do you do it? I mean, how do you find those kinds of companies that will support expanded ideas of a job?
Well, once you know that you're motivated, right, then the opportunity comes when you see a company who is struggling, and there's nothing easier than taking the low-hanging fruit when people are in pain and relieving their pain. So I did it within an organization that had a lot of applications. They had a lot of people. So how do you rise above that? I went out and found the worst performing applications, those groups, those projects that were struggling the most, and just offered to help and just jumped in. And sometimes I had to do a lunch and learn, and I had to explain, this is what I want to do for you. Here's some free pizza while you're eating that. Let me show you what performance testing, real performance testing really is, and what you can get out of it. And they would beg me to help them. And once I actually helped them, I also had a manager who was very encouraging and marketed the fact. So I self-marketed, just like I do on LinkedIn. You know, I got a big mouth. I'm always talking about what I'm doing, right, good or bad, and I'm always poking the bear. There's a little bit of that goes on within a company to create those kind of motivations. But I'm like the Statue of Liberty, you know, give me your tired, your weary, you know, I'll bring them in, you know, we'll make them better. Bring them into my performance engineering machine, and I will make you better than you were before. And once you begin to show value, nothing shows success like success, right? And people eventually in the same organization where I was at, we began to see, they began to see the pattern, and we began to get requests for performance testing, everything from the really, you know, hard stuff to do that nobody else wanted to do, to birthday announcement websites. When they're chasing you down to do a performance test on an internal birthday announcement website, I think you're there, right? So.
Okay, that's thanks for the explanations. I think we are pretty in time. So I would like to big applause for us, because I think we are in time, and it's a perfect moment to give the rights now to Wilson, so Wilson can present a topic related to the cloud. And for those who's been working on the cloud project, you will see it's going to be super interesting.
Okay, I'm trying to find Wilson Marr in my list right now.
No, I already gave the rights to Wilson now, so Wilson should be a presenter.
Okay, all right, great, thank you.
Okay. Yeah. Let me get this set up here. Yeah, what I've done in this presentation, do you see this now?
No, not yet.
How about now?
Yes.
Yes.
Yeah, and I put the word profit from engineering in the cloud specifically as a side title on there, because that's, you know, as Scott says, that's what we need to do, to talk to corporate executives to fund our efforts, and to really get around perhaps, you know, some of this latency, or some of this issues, or you know, protectiveness that some people may have within their system. And I only have 20 minutes here, so what I'm presenting is a very condensed version of what really needs to take a lot more time that I present within companies and within myself. And so my thought is that we can focus just on AWS, which has more capability or capacity than the next two biggest competitors combined, because, you know, versus Azure and Google. What I'm thinking here is that, you know, we wanted to identify issues, and if you have a cloud information system that you work with, there is a tendency now to go from a you know, elastic situation now where you have to configure your own situation, to more of a container service like Docker, to more of a Lambda. A lot of the new applications that I'm seeing now are being done in Lambda, or, you know, functions within Azure and Google. And a lot of companies too, by the way, they don't use just Lambda. They would use both AWS and Azure. So I think that's really a key part. And the issue with them is that with Lambda and functions, these, what they call serverless, is that people think, well, you know, we don't really need performance to look at. And what I'm going to present is really talks about what you need to look for in each one of these, right? Now, the most labor-intensive issue is really this elastic cloud compute, this auto-scaling groups with lifecycle hooks, and those are the things you want to look for in your, you know, when you Google this, right? In your, in order to become a full stack overflow developer and performance guy. So I don't have a lot of time to talk about this, and there are some excellent tutorials on Linux Academy, acloud.guru, and Udemy has a few as well on AWS in their DevOps professional certification preparation. That's where I got a lot of this information. The one thing that you can do as a company to reduce the amount of effort to work with this would be Elastic Beanstalk, where you just give them a jar file and they would just be able to, ramp this up. But in many companies still today, you still would have EC2 instances rather than just, this newfangled stuff. So that's what I'm going to focus on in some of this detail that you can get. Now, if you go to Docker, Amazon offers a registry, and they have Elastic Kubernetes service, which consists of tasks that you execute. And then also they have Fargate. So if you have a Docker instance, you have a container as a service in Fargate, and there's some in the links down there. You can read up about some of the ones. And what Fargate does is it eliminates a lot of this tuning stuff. It doesn't allow you to do any tuning, and that's really a good thing as well, and no performance tuning, right, as a result. But when we go to our AWS serverless functions, I think that you still have to have some performance in order to keep money flowing, in order to analyze the number of of charges that are have. And I've known a lot of people who all of a sudden they get a $4,000 bill at the end of the month and wonder, well, I wasn't really running anything. And I'll give you an example of that exact situation. So one aspect that, regardless of these services that you would use, is to take a look at really the cloud timings, the latencies that you would get. In these two, what I have here is the this cloudping.info is of the AWS. There are other ones available, and if you look at my website here at the lower right-hand corner, you can see a list for Azure and Google as well. But my point, what I want to point out here, is that because right now I got these statistics from Oregon, which is where I'm closest to, and from my desktop to this site, to the Oregon US West 2, is 41 milliseconds. Whereas with North Virginia, by the way, North Virginia has usually the lowest cost instance of any region, because that's where they do the testing and bulk of the testing and new development work usually starts out in North Virginia, US East 1. So if you want to save a little bit of money, you may be able to get a instance in North Virginia rather than, let's say, Osaka, which is, usually a lot more expensive because of that. So, if the difference between the two, the 50 millisecond difference between the two is enough, you may be able to save a few cents here and there, right? The other part of this too is that some people feel that self-hosting is less expensive than Amazon, and that's the case. If you're looking at a lot of different ideas, but there are a lot of reasons why Amazon is actually a little bit better. And primarily, I think if you are a small company, you don't want the hassle of figuring out how to self-host and all, figuring out all the hassles of, buying stuff and so forth. This is actually not a bad deal for them. You have to look at the total cost of this aspect. And that, I think, is really a key part of being a performance engineer, is no longer just saying, okay, this particular application took this long, I'm going to baseline it, and this is how it is as a report. A performance engineer today, in my opinion, is dynamically oriented. It's not just on a baseline and look at differences by version. There are differences all the way across every single day. There are differences. And there are differences not just with the system that you're given, but also look at what other alternatives, and be prepared to answer the question of, hey, is it better to self-host? Is it cheaper to self-host on there? But the key is, I think, is that for us to understand how spiky that load is, and to look at performance in production, so that way we can see that when the spike goes up, how much is the money that are being spent? If it goes down, are we saving any money, and how flexible and how economical it is? So I see this transformation of performance engineers being more performance economists, right, than being just purely a technical viewpoint of looking at the business aspect of things, right? And one of the things that you need to realize is that when you buy bandwidth from a company other than, say, the major cloud vendors, you have to commit to a certain bandwidth for a certain period of time, like 1 year or 3 years. So just that alone, I think, makes sometimes it's an issue for us. And then Amazon does provide discounts for longer term commitments to use specific instance types. And there is, when you use EC2, that really is the issue for you to address, is that taking a look at the discounts available for longer term commitments and what machine instances are really available for you. So let me kind of go through some of these discounts that you should be able to understand, especially obviously when you're in the cloud. Right? On-demand instances are the most convenient and thus are the most expensive, and their prices form the base for which Amazon provides discounts. Right? Apps that are stateful, where it doesn't store a particular user's data right away, must use the on-demand instances, because when you do a spot price, fleet price, it has to be stateless because it can go away instantly, right? So as an engineer, you understand your application. Is it stateful or is it stateless, right? If it's stateless, then you have a lot more options than otherwise, right? And that's why, and you also then have reserved instances, standby instances. And not a lot of people know about this, but if you have a very spiky situation where you don't know exactly when things are going to happen, what some companies do is they would have a reserved state instance standing by, and being reserved, you get about 75%, up to 75% discount on all of these. And and I've got a link at the low right-hand corner that you can see this as well. The other option you have is have a dedicated host instance, making use of the same physical server over time to maintain an existing server-bound license. So if you have like licenses such as Windows Server, SQL Server, or other enterprise license, you would need to have a dedicated host, so that way the license stays within that particular instance and doesn't go away. And then some companies, especially with some, they get audited. I think Oracle does that, and they audit people and they fine them and sue companies because they don't use these dedicated instances to keep track of the license for a particular situation. The other part of it too is this paying up front versus partial versus full. And I don't have time to get into all of this, but that's the other aspect of it that you can do as well. Yeah, the other part of it too is that AWS provides a rough idea of the frequency of interruption of instance type in its instance advisor website that they provide. Here you have a savings over demand of 90%, right? But your interruption is less than 5%. If you look at this other, if you sort it by frequency of interruption, what you see here is that this actually surprised me. See, these 32 CPUs and not filling with 976 memory, these are the rather larger types of systems, and those are the ones that's most frequently interrupted. And this is surprising to me because typically I would think that most people would choose the smaller sizes, like some of this 2 or 16 on there. But one of the things you might want to do when you're selecting these various sizes is to keep an eye on this situation here and how frequently you're interrupted, because if you don't want to have as many interruptions, then pick another one that is not on this high list of interruption. There is a company outfit that gives you a list of ec2instances.info here. That gives you the prices, that gives you the CPUs and how much memory and CPUs, and then by region. As I said, is that the North Virginia is the cheapest one usually, but you have to select the one that you use. And when you look at this list, there are here again the 4 horsemen of the apocalypse, as Scott calls it. It's you've got the balance between the memory, the CPU, the instance storage, this elastic, the EBS backed server. Sometimes you would have a need for only have EBS, so that way it boots up faster. And then the network performance. A lot of people, what they've done is that they select a particular instance type and then see that, oh, okay, it's not running as fast. And they just go up, to the next higher level, when what they could have done was really looked at the storage or looked at the performance of the network to do something about that rather than going up to the next level, which are more expensive. Now, here's a map of the various ones. Now, you saw earlier that this is a metal field, which is relatively new, I think, this year, where they have a much higher performance of this. But notice that there is a huge gap between the highest one, which is rather expensive, versus the more common situation that they have here. Now, the highest capability here is the 25 gig ENA map on here, for the network, and then a EBS for 14 gigabytes per second. The more usual one is a 10 gigabit or even a 5 gigabit on the smaller systems that you select. The suggestion is, get an understanding of those 4 different aspects, the memory, CPU, and the network, as well as the, the hard drive connection, and see where they are. Like, for example, this smaller one would be a C5. That gives you, 72 gig of memory with 192 CPUs. And so now you can go smaller on there, but depending on the kind of network. So every kind of decision that you make, or every specific instance type that you select, has an associated network speed, a memory, and CPU that you really need to kind of bounce across what you need to do. And so let me kind of make sure that you understand here that, the mathematics of all of this and how it works. Now, AWS doesn't make it easy, and that's the reason why we needed to have that website that I showed you, but because they show the different aspects of different properties of these instance types separately in different web pages. And so they show a little bit of one in one page and something else in another, and it's really kind of quite maddening. But when you say 18x large, what it's really doing is it taking the x large as the base, and then it says, okay, we've got x large has 8 gigs of memory, so 18 times that would be 144. And so that's the, the solution for that. And then also you would have 18 times 4 CPUs, that means you get 72 CPUs because of the 18 times, right? Just so you weren't already aware. Now, there are 5 different what they call instant type families that are available from Amazon. And there's a similar kind of categorization from Azure as well, and Google as well. But most of the times, unless you're working with artificial intelligence or doing fancy 3D visualization, you don't need to worry about the accelerated computing. Or if you use data warehousing, then you need to use the storage optimized. And these categories, these instant types change all the time. That they have new stuff that's coming along. Like we said, it's like if you use a really high video encoding type of application, you might want to choose like a C5. And if you have a general web page, for example, most companies, they would choose like a T3, T2, and what are called burstable. And there are differences between the way, if you do a M5 versus a T3 or T2, M5 is not like really burstable. You have, and I'll get into what that burstable means in a minute. So you need to really do an analysis of what is the cost for your particular application profile in order to get the maximum use of it. And that's how you show profit, is that by reducing costs, that you'd be able to do that. And because these are really performance aspect, this is above and beyond what we traditionally do, capture of the response time. Here, we really need to look at the server. And I think with the cloud, it gives us a golden opportunity for performance engineers to elevate their capability by looking at the economics of this whole situation. Because now, unlike in previous past, you're working on a mainframe, for example, you don't have a choice as a performance engineer to say, hey, maybe we should, create a, use a newer version. But with cloud, you can just switch it very easily, and you'd be able to save this company, a lot of money, okay? Especially if you have a lot of systems. Now here is a CloudWatch image of the credit balance. Again, I don't have time to get into all of this, but the idea is that you have some surplus, you have some credit limits, you have some surplus credits. And let me go into that very briefly, because if you have EC2, this is something that you need to know. There is a CPU balance additional, really this is a additional dimension of this in addition to CPUs. And you can accumulate credits and then also spend credits if you go up and down on the baseline. And that baseline really is more like the average that you have. And if you look at a web page from Amazon, for example, if you want to select a T3 small, you would get 2 CPUs. They would give you then a 20% baseline of CPU. So if you go above it, you will spend credits. If you go below it, then you accumulate those credits. And so that would be the level of 24, let's say, per hour that you would accumulate if you go below this, what we call an average. But the crazy thing about this is that that is an average, and you need to figure out ahead of time what it is. It's very similar to your telephone bill or your like Verizon bill that I have. And they said, okay, you have to pick before the end of the month what's going on, that you can, will you use unlimited or you use, 2 gigabytes. And then at the end it says, okay, we can give you some, leftover credits. And this works the same way on here. So this is 20, let's say, for example, if you have that, you can accumulate, the next hour, then you would end up with 48 instead of 24 and so forth, right? There is also now the question of what happens when you go above that allocation, that if you give that 24 and you already spend it, what happens? That surplus, then they go into this surplus credit balance, a second level that you have 24 hours to use up that credit balance if you go above this average dotted line here that you see. Again, it's very complicated kind of a situation here. I don't have time to get into, but if you go above the surplus, they'll charge you an extra 5 cents an hour in order to take advantage of that. So the question here is, well, what if we have this T3 small? If we go through that, then there's this calculation of how to get to the maximum that credits you earn before you have to jump into this, extra level of additional costs. So now you say, well, why do we need to go through this with the T3s? Why can't we just pick an M5 and be done with it, right? And the reason is that if you have not a lot of usage, then you would be able to, work with this work with this lower end. However, if you have a lot of data that the machine caches, or a lot of data that your machine will work on with EBS, the local image, then you would need to go up to a higher EBS bandwidth in order to accommodate that, because otherwise you get charged extra for that as well. So the other part of it, so here, and again, I'm not going to go over this very much, because this is a calculation of the difference between the two here, and I need to fix the heading on that. So my suggestion is take a look at the documentation and educate yourself on this, because the better you understand your application, the more effective you can make your auto-scaling architecture, right? So the two key aspects of it is how long does it take to launch and configure a server, and what metrics have the most relevance to your application's performance. So let me dive into that a little bit more, right? And let's go back to this chart here. We would use the reserved instances that we talk about. We would, use some spot on-demand inferences for the high end, and then we would have, like, starting with a minimum and maximum sentences, instances that you would have, and then, as it goes up, then you would, add additional up to 9 in the scaling groups. But here again, the problem is that you have to specify ahead of time what is the maximum. So, for example, if you are a Super Bowl commercial, how do you know whether how many is it 9? Is it 90? How many people can you? It all comes down to how much you can afford. So this number really is how much can you afford. So if you have a business model that is that the more people visit, the more money you're going to earn, then that is you would probably put that pretty high. But if you're like a nonprofit, for example, and you can only take so many, then you would want to set this according to how much budget you have for that month. Otherwise, you're going to have a problem. So knowing the budget and knowing the business model is really a key part of what a performance engineer needs to know nowadays. Okay? You would also need to come up with, based upon all the stuff that I've talked to you about, come up with some. This is just an example. And what is missing from this is the load balancer is missing from this, and the labor is missing from this. So this, allocation between self-host and Amazon is really a kind of a technique for you to get a better understanding of the business of doing this performance engineering. Okay? And here's some examples. You can work with that. And there's been some debate. This was from 2002, but then debate continues, right? Now let me go through real quick here is what you may be missing. We've talked about machine types being too small. If it's too small, it's going to be unstable, right? And there have been studies that have shown that a T through small is really too small for many situations. If you select too high, you're paying too much of machines that are too large. And then also, if you are just select one, you may be paying for unproductive time during setup. And that's the next topic that I will tell you about in terms of traditional performance testing applied to cloud, how you can get this unproductive time figured out if you're waiting too long. Okay. And also, if you don't scale fast enough and using storage that's too low or too expensive. So let me go through real quick here. It's like we start out with a stress test. We then look at UX degradation. So I don't stress test it all the way, because in the cloud, you really shouldn't be. You look at stress test your application until you get UX degradation, and then back off from there to figure out what is the lead time before you get to UX degradation. And that's the point where you take action, right? That you actually add another server. But that instance, that additional server, you have to look at the difference between a nominal actual average, that we just talked about, that average, find out what that is for your application, and then ramp up to that in a actual test. And then from there, you can, then that really defines the headroom that you have to between the time you take action and the time of the actual headroom, and it would be the actual time that you would need to have. Because really, you're talking about the amount of lead time in respect to the effort, in respect to the actions that need to occur, right? And then with spike capacity, we would ramp up and be able to see with a spike test, be able to see that, we would look at the CloudWatch for RAM use, CPU use, disk use, and so forth, the 4 horsemen, and look at keeping track of that. And then when we scale up and down, it depends on that. And I've got just about 2 more minutes. Okay, does that work for you? Okay, so the idea here is that we want to be able to scale up and down for 2 aspects. One is up and down for the instance types that we want to select, and then each of the instance types will be replicated in an additional scale up and scale in and out. And when we say in and out, it's really additional instances. Up and down is when we have different instance types, and a lot of people confuse this very aspect. So when we scale this up, we want to be able to see when a scale out occurs, and then also we want to have a capability as engineers to try out different instance types in this run, in this profile or this scenario, if you will, so that way we can see when we use different instance types, are we losing the different, is it longer, and are we losing RAM, are we losing performance as a result? Okay. So that really is really the key aspect of this, and then being able to configure the average, the CPU utilization. You can change the trigger points for your your timing of your run tests, right? The takeaway here is that if you don't want the hassle, Dockerize and use Fargate or write serverless functions. If you're willing to sacrifice network latency, use the cheaper regions. You know, steady, large bandwidth is what telecoms want you for self-hosting. Unless you have a large bandwidth and it's steady, it's really better to stay with AWS or another cloud. And you need to experiment to get the best EC2 instance types under future full load requirements of memory and so forth to find the bottleneck and see which one is the bottleneck. Is it the memory, CPU, disk, or network, right? And then standby instances so that way it absorbs instantaneous additional capacity, additional work while the additional servers come back up, right? And then measure time during startup to determine the buffer values that you need to have, right? But more importantly, if you're going serverless, you still need to monitor memory use because you're paying for every single byte used. So even though you're going serverless, performance engineering is not over. You still need to measure the memory use. Okay? All right, so anyways, that's the I wanted to cover with you. So thank you for the time, and here's some information. Feel free to send the LinkedIn to me, and we'll get you going.
All right, thanks, Wilson. That was awesome. I think you make the point. It's not because you're moving to the cloud or you're using serverless or you have elastic architecture that you don't need load testing. So how many people I heard that sentence saying I'm moving to the cloud or I am purely elastic. I don't need performance testing, but cost is obviously the reason why you want to control how your bad code or good code is behaving. I think I have there are a couple of great questions, and I in fact when you were presenting, I had those questions as well because during Chamonix PAC of Chamonix, we had one of our PAC member called Tuan Kot, so he made a presentation about CPU usage. And today we have the honor to have Tuan here connected. So I'm going to promote him to be organizer, to the panelists, so he could share his webcam and ask his question directly. So Tuan, please share your webcam. Hi, Tuan.
So, hi guys.
Hey, Tuan, you're a mystery guest.
Yeah. So I was looking at the webinar, and of course it's about performance. So then I need to join in. So you guys can hear me all right?
Yeah, I can hear you well, in fact. And
Yep.
I think, I will let you ask the questions, but one of the things there, you referred on the previous slides, for example, and saying, if you go back to, Wilson, to your previous slide, you were, you just stopped sharing your screen, so, but you were referring about
sure.
CPU usage. And there was a few questions about a few things about CPU in general. So, for example, if I consume 80% of CPU, I want to be able to spin up instances. So I think Tuan had a lot of questions about that because his presentation was related to that. And I think you could. I will let you ask the question, Tuan, but I think I would like also you to remind. Why CPU percentage or whatever use it doesn't mean anything, especially in the cloud environment.
Yeah. So I was wondering because you're looking at different instances and how many vCPUs are allocated to these instances, but we don't have any idea how much power is really behind these vCPUs. They're just a thread on a CPU, which AWS is giving a certain amount of power to these vCPUs. Secondly, we don't know how busy the whole system is or the certain amount of racks. So comparing cloud performance is really hard because we don't have the big picture. We don't know how busy is the host. Is it a slow day? Is it a really busy day? And secondly, looking only at CPU utilization, you're missing out on the scheduler, so multi-threading, those things. We don't have any idea about that when it's only talking about vCPUs.
Yeah, frankly, I think that Azure has a lot better approach to this because you can use in Azure, you can use the RAM usage, you can use the CPU, disk queue, I think is a big one, and also the network usage. All four of those can be used as the basis for scale up and down on Azure. I think that's really a nice thing. But within the AWS realm, you're right. I mean, the CPU percentage has been an issue from day one within Linux, right?
Yeah.
Right. It's always been an issue and a very, mystical kind of a thing because it's so freaking complicated, right? And it's really unnecessarily so. But and then also too is that when you have a spike, how long would it be, right? And the problem is right now it's 5 minutes. Is that, and within 5 minutes, a lot of things can happen, which is then why we need to have a reserve instance in order to absorb the issue. So, I mean, all this leads to more equipment that we have to buy from AWS.
Yeah, but in fact,
I think it's design.
When you look at the architecture, I mean, the rack is here, the disk is there, the storage is somewhere else. So basically, you're spending your time waiting. I mean, the CPU or the host that you have at Amazon is basically waiting to get the data from the disks or whatever. So I think that's a big challenge because we are playing with latency here in those data centers.
Yeah, for those people who have an option, I think Google's got the fastest interconnection between the servers, and their Google Fiber connects to all the various regions much faster than all the other ones. So I think that is a huge difference there.
Yeah, so I think that's one thing. So maybe Tuan, could you just remind us the tools that you were recommend to measure the CPU? I mean, I know that in Amazon or Google Cloud or Azure, we don't have those tools obviously available, but I think it's just to remind how you can measure the latencies, where you're spending the time, why your CPU is high. I think that could be a great thing to remind to the audience.
Yeah, so if it's purely based for Linux systems, so Unix, you could use PCC collection. So this is based on eBPF, and that's some new features, and those are in-kernel sort of VMs, and you can use them to measure deeper metrics, so you can check the scheduler latency. And the issue is you only have the scheduler latency from your vCPUs or your instances, and you have no idea what the actual latency on the host may be. So, but you could measure how much latency a particular process has on the CPU. Yeah, so that's why. But again, it's all cloud-based. We only have a small picture of the performance or the metrics. So that's the advantage of self-hosting. I think you have control over the CPU. You know how powerful the CPU is. It's always the same power. It's not fluctuating. Well, not anymore because we have turbo processors. So also fluctuating performance there. So that's to me that's really the downside of going to the cloud. It's the performance is fluctuating.
Yeah.
Yeah, a lot of people had to do a distribution, especially with the cloud. They would need to just play tricks like having multi-RAID, higher RAID than they need to in order to get the performance up for disk access. Yeah, so there's a lot of little tricks to it. And also, too, I think that there's really less incentive the more that Amazon gets to this Fargate and, these situations where it's all completely as a cloud, the more they offer in terms of, analysis, right? On the EC2 side, the less incentive people have to go to this Fargate and other containers and service capabilities.
Yeah.
Whereas that's not the case for local, right? There is a case, by the way, is Amazon does offer now, beginning to some data centers, and even the one here, they have this one where actually you can run Amazon services inside a local instance, I mean, in your local data center that you can contract for. Outpost, I think AWS Outpost, it's called.
So I probably have a question that could be mixing Scott and you, Wilson. So if you want to control the cost, we have to figure out a way to expose lively the costs or predict the cost of the environment if you were going on production. Because here basically we're selecting specific instances. We know in average what will be the cost per hour of one node of the architecture. So we could predict what would be the average cost of, let's say, of a production hourly base or say or a daily base, whatever. So that could be a really great KPI to share to the project or to the stakeholders, saying if we're going on there in the production environment, that will be what you will spend with Amazon, for example. So I think we have to come up with an approach or something that could easily, it will be a way for performance engineers to collect and report back that cost. I think that will be great. What do you think?
Well, the trouble is that it's very difficult to see ahead of time, especially for new. Like, for example, just the other day, I had this bill on one account that had supposed to have nothing in it, and it charged me like $15 every month for directory services, and that's billed by every hour. Right? You ran into that, Scott? And I'm going like, what is that for? Right? But it turns out that it was needed in order to do some other thing I did, which I terminated. Right? Those instances I terminated, but the directory service, still was running, being billed on a per hour basis. That's the same thing if you have a IP address, it will bill you every hour if you don't get it attached to a particular system. And there's a little kind of nickel and dime kind of situation that you're going to have that you have to watch out for, which is important. And also too, if you get your account stolen, you can have up to like $4,000 or $5,000 of somebody else, mining their Bitcoin thanks to you. So this kind of stuff really needs to be looked at, and it needs to be set up by a technical kind of a group, not just some accountant who's just basically just taking the bill and paying it. And it really needs to have somebody. And I think that performance engineers are the ideal group to look at the accounting of this, in addition to just the technical aspect, because it does take some technical savvy in order to understand what all these different line items really mean.
Yeah. Yes, it's really a cool idea. I believe Dynatrace is already pushing some of these metrics into the dashboards, but measuring how much a Black Friday costs you extra for all the instances is maybe a good idea. Go ahead.
And I think like this, like for example, this thing that's in front of us here, this is really a calling card for performance engineers to walk into the various departments and say, hey, I'm tasked to come up with this analysis here, from the auditors and so forth. What is this line item, in terms of what that means? And so that way you can collect from all the different people, all the different departments, and working together is needed in order to come up with a full estimate of what's going on. But also too, I think there's stuff like CNCF has the Zipkin. Amazon has the X-ray that looks at the very precise amount of time between the various instances, and I think that would be good. But the problem is that it's not cheap, right? To collect every single call by every single service and every single Docker instance, that's very expensive. And so, but they offer it, so I don't know, very many companies who could really afford it. So I don't know, is that in terms of X-ray versus Dynatrace, I was curious what your thoughts are when people are looking between the two.
I think I won't say much because I have already my preferred partner. It won't be very interesting to share that, but yeah, you already know what I think about it.
Well, what I'm saying is that's an experiment that really is necessary. Is that every time AWS comes up with a service, we really need to take a look at the differences between third parties, right? What they have to offer, and because not just lock-in issues, but also in terms of cost and benefit as well. So oftentimes, your third party is just as good as, if not better and cheaper than the options that you have from AWS.
Yeah.
So I think it really is worth looking at in terms of a comparison, so that way we can see economically what the issues are, and in
Can I
balance.
jump in here for just a second?
Go ahead.
I just want to jump in here just to say that, Henrik, you were asking about how do you transform from just being a performance tester to a SEAL, or moving from a tester into an engineer. What Wilson's done here, this is the kind of thing somebody wanting to break out of just being a tester and moving into an engineer does, especially if you're the self-motivated kind that walks in and says, I've been doing performance tests for you, but hey, let me take a look at this AWS bill, see if I can help reduce some of the costs. That's an engineer directly impacting the business financially, and this is the kind of thing that a SEAL would do. Knowing how to do a spreadsheet is not necessarily that technical, right? But it's the concept of addressing it in the realm of performance, and this is what we need more of, I think. So I just wanted to offer that.
Yeah.
But the difference is I had to get up every day like 5 a.m. and put my personal time into this thing. And I wish that more companies would offer time for these performance, people to come up to speed on all this stuff that I talked about. And if you're a good manager, then you allow your people the time, to look into this stuff and to take the, A Cloud Guru exams and, and preparations, so that way they can learn all this stuff.
That's right.
Okay, so I think we are running way out of time, but we still have some attendees. So I'd like to thank the attendees to be still connected and listening to to our discussion. So it was really great. So first one, I would like to thank you to be connected.
Yeah.
We'll
Thank you.
connect you, and I'd like to conclude this webinar. So thanks, Tuan, and
thank you.
I hope we will see you for the virtual PAC.
Well, I have some good talk in planning, but won't share anything yet.
Okay, thanks, Tuan.
Yeah, bye.
All right, so I'd like to thank you, Wilson and Scott. So Wilson has disappeared. I don't know why.
No, I'm here. Yeah, I just turned off my lights here.
So thanks for this webinar. I think that we had a lot of was really interesting. I mean, from my perspective, I thought it was really interesting. I hope that everyone here, all the attendees, has enjoyed this 1 hour and a half almost session. So thanks a lot. So thanks, Scott. I think you make the point. I totally agree. Align with the SEAL approach. I think it's we have to teach and force people to get out of the pure test validator or performance testing in continuous testing approach, and moving and get out of looking around them and figure out more business things. So that you make the point. Thanks, Scott, for that.
Thank you.
And Wilson, I think bringing up those the things. I mean, I know it was a bigger challenge to expose everything in 20 minutes. So I think you make the job. And I think the cloud is a great concept for architecture. They bring a lot of freedom, but it's really expensive, and I think controlling the cost is a key. And I think it's even more. It's just awesome for us as performance SEAL engineers or performance engineers to be able to not only validate response times, but be able to be an advisor in the cost of the infrastructure. So that's I think it's even better than performance testing back in 90s or in 2000s where we were just fighting pure only response time. So that's great.
Yeah, we didn't need a song, Scott, like the Baby Sharks, like R.
Yes. Tell you what, I'll play the guitar, you sing.
Okay, so I think we're going to close the webinar. So thanks both of you, and I hope that also you'll be part of the next PAC. So don't forget to. I know, Scott, that you already submitted your paper. Wilson, I'm not sure. I have to check that. But if you did not,
Yeah.
don't forget about it. And otherwise, talk to you soon, and we will publish this video in the PAC website. And Scott, see you on Thursday then.
Yes. Yeah, looking forward to it. Thank you, guys.